Hello friends, in this video we're going to solve Dibrugarh University BSc Physics question paper Digital System and Applications of 2020, right? This exam was held in April-May 2021. Physics, BSc Physics. In the first part we have already solved question number 1 to question number 4, right? And here we are going to start from question number 5, and it will to complete this paper I have to make 4 or 5 videos, and after one video, at the end screen of the video, the next part will appear if it is uploaded. Okay, if not uploaded, then you have to wait till it will upload it again. And please subscribe the channel if you are new to my channel, and also hit the bell icon so that you get notified when new video will be uploaded, and share with your friends and help me to grow my channel. So now let's start. So this is question number 5. Here we are to prove the De Morgan's two theorems. So what are those? So first one is your a plus b complement, a complement dot b complement. Let me prove this one first. Okay, so let us take that x is equal to a plus b, and y is equal to a complement dot b complement, right? Let me take this way. So here you can see, first let us find x plus y, right? First let us find x plus y, that is a plus b plus a complement dot b complement, right? A complement dot b complement. So then what you can do here, so we have a property that is a plus a complement dot b complement, or b, uh, a plus a complement dot b, then you can write a plus b, right? So we have this property a plus a complement b, then you can ignore this a complement, then you can write a plus b. So similarly here you have b plus b complement dot a, so in that case you can ignore this b complement, so you can write a, b plus a complement, right? You can write a plus b only, sorry, b plus a complement only from these two using this property, right? So as you can see, we have a plus a complement b. So as I have ignored here a complement, just read a plus b is written. Similarly here you can see that when you have b plus b complement a complement, so you can compare you can you can ignore this b complement when you have b here. Okay, so then what you will get, according to this property, you should get b plus a complement only, right? So this is what we have got. Then now you see a plus a complement, a plus a complement plus b, a plus a complement, that's going to be 1 plus b, a plus a complement is equal to 1, and 1 plus b, that's going to be again 1, right? This is a property. Okay, uh, 1 plus a, that's going to be your 1, right? This is a property of Boolean algebra, right? So now you see, let us find x dot y. Now let us find x dot y. So x dot y, that means a plus b dot a complement dot b complement, then use distributive property. So let me separate these things. Okay, so then what you will get, a into this, then b into this again, right? So a dot a complement dot b complement plus then b dot a complement dot b complement. Now here you see a dot a complement, that's going to be 0, so 0 into anything, that's going to be 0, right? Then b dot b complement is also again 0, so here we're going to get 0. Now remember, now you see, if you compare this to, so since we have got x plus y is equal to 1, then x dot y is equal to 0 and x dot y is equal to 0, and this can be possible when y is equal to x complement, or you can write x complement is equal to y, because you see we have a property that a plus a complement is equal to 1, right? Or a plus a complement, that means a plus a complement is equal to 1 and a dot a complement is equal to 0. So if x plus y is equal to 1 and x dot y is equal to 0, according to this property, this y must be x complement, right? So that's why we can write that, let me clean these things. That's why we can write this y is must be the complement of x, right? So here we have followed that property, and in this case, so what is x? X is nothing but a plus b. So we can write instead of x a plus b complement, because we have x complement here and x is a plus b, right? Is equal to y is your this a complement dot b complement, a complement dot b complement. So the first property is proved. So now let us prove the next property. Pause the video and note it. And the next theorem is your a a dot b whole complement is equal to a complement plus b complement. This is the next property, next theorem. So let us prove this. In order to prove this, let us take x is equal to a complement and y is equal to b complement. Let us take that way. So in that case, let us do x plus y. First let us find x plus y, then it will be a complement plus b complement. Okay, now you can see we have another property that since a complement, again you have complement, then it gives a, right? Or you can write since complement of a complement is a, therefore we can write that x plus y whole complement, again we can write complement, right? So if you do so, then what you will get? So according to the first theorem, De Morgan's theorem, that we have already got, that a plus b complement is a complement dot b complement, right? So here if you apply this here, that means you can apply here x plus y complement, you can write x complement dot y complement. So that's why we can write this as complement of x complement dot y complement using the first De Morgan's theorem. Okay, and that means since a plus b complement is equal to a complement dot b complement, I have used this property. Now what we can do here, you see x is a complement, so replace this x by a complement, then what you will get? Complement of a complement dot complement of b complement, right? So as we know that complement of a complement is a, therefore we can write complement. So this complement of a complement is a, similarly complement of b complement will be also b. So that's why here you can say that we can write complement of a dot b is equal to a complement plus b complement, right? So here you can see because on the left hand side you can see complement of this complement, again you can write x plus y, and x plus y is your a complement plus b complement. So this is proved, right? So this theorem is proved now. Okay, so hope you have understood this. So now let's move on to the next question. So this is question number 5b. Here we have two questions, this one or this one. Okay, I'm going to show both. So first let us solve this. Okay, So using Boolean algebra, we need to show this relation. Okay, so now let us show this. So here you see AB plus AB complement C plus BC complement is equal to AC plus BC complement, right? So here you can see, uh, let us take the left hand side first. Let us take the left hand side. A plus AB plus AB complement C plus BC complement, right? So I have taken the left hand side first. So now here you see, this AB can be written as we know that A plus A complement is equal to 1, so we can write that AB into 1, and this 1 can be replaced by C plus C complement according to this property, right? So now we have written this way. Then let me write the other two terms as they are: A B complement C plus B C complement. Okay, so now use the distributive property, and doing so A B C, then A B C complement, right? This one with this one with this, right? So hope you know these things. These are very simple, right? A B complement C plus A B C complement. So here what we're going to do here, you can see that if you observe these two, that you must have observed that here we have BC complement, BC complement, right? Let us take these two common. So then what you will get, and other two terms, observe other two terms. So here you can say AC can be taken common, right? So let us do so. Then AC taking common, you have got B plus B complement, and on the other hand, from these two terms, what you will get, A plus 1 BC complement. So because here you see this BC complement can be considered as 1 dot BC complement, okay, and BC complement is taken common, and doing so what we have got this result, right? And from these two we have taken AC common, and we have got this result, right? So hope you have understood this. So now what we can do here, so B plus B complement, that's going to be 1, so here we have got AC, then A plus 1, that's going to be 1, right? A plus 1, that's going to be 1, this property of Boolean algebra. So let me write the properties that I have used here. Since B plus B complement, right, B plus B complement, that's going to be equal to 1, and A plus 1, that's going to be again 1, right? So this relation is proved now. Okay, so this is the this is your right hand side, right? So hope you have understood this. So now let's move on to the next question. So here we have to use the K-map, right? So how to use that? So as you can see, you have 4 variables in its terms, so 2 to the power 4, that's going to be 16. We have to make 16 blocks, 4 rows and 4 columns, right? First let me write the given expression. This is the expression we are to simplify, right? Okay, so here as we have 4 variables, so we have taken 16 blocks, right? 4 columns, 4 rows. And suppose if you had 3 variables, ABC, 3 variables, then you have to take 8, right? That means this way you have to take 8 blocks, right? 8 squares. Then if you had 2 variables, then 2 square 4, then you have to take only 4 yes, 4 blocks, that 4 squares, 2 rows, 2 columns, like that way. And when you have 2 variables, you have to write 1 variable on this side, another on that side. Similarly, you have 3 variables, then 2 on this side, 1 on this side. And if you have 4, then A, B, C, D, then other also. So here we have to write AB on the other side, CD. That's how we used to do, right? So that is the way that we should do, right? So now you see, so what we're gonna do here. So first you have to write 0 0, right? Then add 1, you will get 0 1, right? Then if you add again 1, you should get 1 0, but here you cannot write 1 0, because you know, when you write the next number, only one bit should be changed. Here you see 0 is changed to 1, 1 is changed to 0, 2 bits are changed, so you cannot take 1 0 here. Again, if you add 1 here, then you should get 11. So sorry, 1 1. Here you see, if you see these two, then 0 is changed to 1, then 1 remains 1, only one bit it 1 bit changed. So that's why we're going to write 1 1 here. Instead of writing 1 1 on this block, we're going to write here 1 1, because here only one bit is changed, that is 0 to 1, 1 remains 1. So make sure that only one bit is changed. Then again 1 0 0 0 0 1 1 1 and 1 0. Similarly on this side also 0 0, then only change one bit, then change this bit, that's going to be this, then change this bit again 1 0, right? So hope you have understood. Then you see, if you express this one into decimal, then it's gonna be 0. So just you don't have to convert, don't have to follow the conversion process. Just simply you have to write 1 2, then don't fill the square that is at second from the last. So first fill this. Here you see, let me show you again. 0 1, don't write here 2, 2 should be written here, then 3 come back here, then again 4 5 6, so this 6 should be written here, then it should be filled with 7. And again similarly, as here you see, you have filled this one, then this one, then you came back to this. Similarly, while going from top to bottom, you have to fill this one, sorry, you have to complete this row, and this row, then you have to come back to this row, right? So here you see, after filling this second row, we will go to, so after completing this second row, let's fill this last one. So here it is 7, so we're going to start with 8. So 8 9, then don't fill this one, this is 10, then here it is 11. Then after 11, let's go back to this the second row from the last. So we're going to start with 12 13, then go to the in block, that is 14, then come back to this is again 15, right? So these numbers represents the corresponding decimal numbers of these terms. Okay, so not these terms, sorry, this here you see, yeah, if you say this block, so here you have AB and CD, and both are 0 0. So all ABCDs are 0 0s. That means this represents A complement, B complement, C complement, and D complement, and its corresponding decimal number is 0. Okay, so that is what this map represents. Okay, and then here you see, now this block. So here 0 0, that means A complement, B complement, this is 0, C complement, then this is 1, means this is D, not D complement, only D. So it represents 1. So hope you have understood this, right? So now you see, uh, so let us write here. Now you see, this is 1 1 1 and this is 1 1 1. So we have D complement, put 0, then again this is 1 0, again 1 1, and this is 1 B complement, where you have complement, put there 0, then again 1, then 0. When you got complement, input should be 0. Okay, so that's that. So now which term represents which block? That blocks will be filled with 1. Okay, so 1 1 1 1 A B C D. Okay, 1 1 A B 1 1 here, then C D, this is 1 1, this A B C D, so comes to this block, so this should be filled with 1. Okay, so hope you have understood this. So this is 1. Now A B C and D complement, this is A, then this is B, then this is C, and this is D complement. This is A B C and D complement. So then its corresponding block is this, right? Put here 1. Okay, so similarly, just wait. Then next one, A B complement C D, A B complement. So this is A, this is B complement, right? Then C D, this is C, this is D, right? So what will be the corresponding square? So come to this and this, so then it's gonna be 1, right? Let's put 1 here. Then next we have 1 0 1 0, this is 1 0, that means A B complement, then 1 0, again C D complement, this is C D complement, right? So that means the last, these two represents the last block, right? So now you can group the ones. Okay, you can group the ones like this. You can make groups of these ones, group of 2 ones, you can make group of 4 ones like this, and those ones should be adjacent. That means, now you see, suppose you have, let me show you something. Now you see, suppose just wait, suppose you have one here and one here, you cannot make groups these two ones. Okay, so suppose you have a one here, you have one here and another one here, then you can make this two as a pair, because these two, this one and this one, will be considered as adjacent. Okay, now again you see, you can make the group of 6 also, you can make the group of 8 also. Okay, depending on the K map. And here you see, suppose you have one here, then another one here, you can overlap. You have made pairs here, and you cannot make group of these odd ones. Okay, so you can make pairs and you can overlap also, but each pair consists at least one unused one. Okay, so there should be at least one that which is not already used in another pair. Okay, so hope you have understood this. So now let me clean these things. Okay, so now let's simplify this expression. Okay, so how to simplify this? So here you see, this is the one. So what we have here, sorry, so this is A B and C D, right? And this one represents AB, then CD complement, and this block represents AB complement, and this one represents sorry, this block represents A B complement, then here it's corresponding, this one is C and D. Then the last one, this one, it represents that again A B complement, then C D complement, right? So in this four terms, what you have seen common, so here is C, here is also C, but D is not common because here it is D and there is D complement, so eliminate these two. Then here we have, in these two you can see you have B and B complement, so we're not gonna take this. Then we have A common, A in common, so our simplified expression, so what are the things that we have got common? A, and from these two we have got common C, so this is the result, AC. Okay, so this is the simplified expression, this is the simplified form of this given expression. So hope you have understood. So if you have understood, please share with your friends, hit the thumbs up button, and if you are not if you haven't subscribed yet, please subscribe the channel, also hit the bell icon so that you get notified when new video will be uploaded. As I'm gonna complete this paper in 2 or 3 videos more, I need 2-3 videos more, because I cannot complete all the questions in the same video, because it's gonna be too long. So stay connected, and when the next video will be uploaded, it's gonna appear at the end of this video. Okay, so I'm using the end screen features. Okay, if it is not uploaded, then you are not going to get that one at the end, but when it will be uploaded, you will say, you can see that those video, that next part will appear at the end of this video. So hope you have understood what I have explained till now. So thank you for watching, see you in the next video.